Okay, so yesterday, since we met, I have become much more tech savvy and figured out how I can get this information to you guys a little bit better, even if we're not actually together or in case you can't make the Google Hangout. So I have the notes open on my computer and I'm just going to go through and write down what I would have written down if we were in class on the board. So basically, U-Substitution we're going to use to undo chain rule. Or it's the inverse of chain rule or the antiderivative of chain rule. So if I look at the problem, the integral of 12x squared, the cubed root of 4x cubed plus 7 dx. Right off the bat, that is pretty intimidating and it's got a lot going on, so I want to kind of simplify it in order to make finding the antiderivative easier. So what I'm going to do is if I look at this 4x cubed plus 7, I notice that the derivative of 4x cubed plus 7 is 12x squared, which is in my equation. So I'm intentionally going to pick a u. I'm always going to pick a u. That is something I have the derivative of in my integral. A good shortcut is normally it will always be something that's inside of a root, or is in parentheses all raised to a power, or is inside of a trig function. Those are the things you want to try and pick first as your u. I can always double check myself and make sure I've picked the correct u by finding the derivative, or du. When I find the derivative, I get 12x squared dx. Since I was taking the derivative of x, I want to make sure I write dx after that so that anyone who is reading my work knows that x is my variable. Now, because I have my u in the equation, and once I found my derivative, I have my du in the equation, I know I picked the correct u. If I didn't have my du in the equation, then I would go back to my problem and try and pick something else to be my u and check to see if that derivative was in the problem. Once I have done this, I'm also going to find dx, and the way I'm going to do that is I'm just going to solve this equation up here. So I'm going to divide by 12x squared on both sides so that du ends up being all by itself, or dx ends up being all by itself. When I do that, I get dx equals du divided by 12x squared. Oops, forgot my squared up here. All right, so the reason I did that was because then I can go back and I'm going to substitute into my equation. I'm going to substitute in my u, and I'm going to substitute in my dx in the equation. I'm not going to mess with the part I have highlighted in red yet, because I'm hoping that if I did everything correctly, it's going to cancel out. So when I go back in, I'm going to keep my integral sign because I haven't taken the antiderivative yet. I'm going to rewrite 12x squared. Inside my cubed root now, instead of having a 4x cubed plus 7, I'm going to replace it with u because I've said they're the same thing. And then instead of writing dx, I'm going to replace it with all of the, wanted the highlighter, all of this. So instead of dx here now, I'm going to have du over 12x squared because I said they're the same thing. Now I know I've set it up correctly because then I see over here I'm multiplying by 12x squared, and over here I'm dividing by 1, so those will cancel out. So now my integral becomes the cubed root of u du, which is much easier to solve than what I started with. If I'm going to finish solving this, I'm going to keep my integral sign. I'm going to rewrite the cube root of u as u to the 1/3 power du, and then I'm going to solve it. So I'm going to say, okay, to find my antiderivative, I have to add 1 to my exponent, which is really like adding 3 over 3, because I need common denominators when I'm adding fractions. 1/3 plus 3/3 gives me 4/3. Then I'm also going to divide by my new exponent plus c. I'm going to simplify this by taking the reciprocal of the 4/3 so that I get 3/4 u to the 4/3 plus c. And then my very last step is I want to plug back in here to my u so that I have x back in my final equation. So my final equation, or my final answer, is going to be 3/4. Instead of u, I'm bringing back my 4x cubed plus 7, all to the 4/3 power plus c. And that would be my final answer. Now, I'm going to do this anytime I have two functions in my equation, or anytime I just want to simplify my integral so that it's easier to find the antiderivative of. Thank you, Logan.